Hey, Hudson. How you doing tonight? Doing all right. So I think the first thing I kind of want to get started with tonight is right now you just kind of float through enemies. You take damage, but there's no, I don't know, effect on the player. I'd like the enemies to be a little bit more solid. So I'm going to try and do something about that. I don't know exactly how I'm going to manage it. So, if we touch the enemy while not invulnerable, and right here, I want to do something with the player's velocity. It's really fun. Like, if you haven't picked out a career, programming is, I mean, it can be rewarding. Other times it can make you feel like an absolute idiot. But it's good, challenging work, and it's really fun to be able to do these kinds of things, to have an idea, and then to be able to kind of sculpt it. Tiny bit of Java. Java's a good language, very powerful. A bit wordy sometimes. Like a lot of the functions in Java tend to be a little bit longer to write out, I guess is the best way to put it. Not really good though. I mean, any bit is probably better than average. So how do we want to do this? What does this look like? When I bump into an enemy, so we got to think about the fact that we could be moving towards the enemy, or we could be stationary with the enemy moving towards us. Or, weirder still, we could be moving away from the enemy, but slowly, and the enemy could catch up to us. And we want to bump the player's speed up to the enemy speed there. How do we handle that collision? Thinking back to physics class, elastic versus inelastic collision kind of stuff. I don't want the enemy to slow down. Took coding class last year in school just by chance, really did not enjoy it because of the garbage teacher. Yeah, a lot of it is like, I will say the absolute best way to learn programming is to actually enjoy what you're trying out. Like, for me, that's why I like playing, making little games so much, is because, like, that's fun to do. It's a small project, typically, that's just really fun to kind of tweak and mess around with. Yeah, and the fun thing is that, like, the reason that I am a proponent of JavaScript for that is when you have something built that works, you can basically just send somebody a link to it and they can try it out immediately. So if you build something that you're proud of, it's very easy to show it off. Versus things like Python, where, okay, you got to install Python version 3 point this and make sure to have this version, not that other version. it just becomes a lot harder to show off what you've done without learning a lot more about how it works. All right, so how do we make them bounce off the enemy? Let's get out our trusty Microsoft Paint here. Can't go wrong with Microsoft Paint. All right, we got 2 entities here. Is JavaScript easy just because it is set to... So, the thing that makes JavaScript easy for showing off, in my opinion, is because unless you're doing some big project like I am, where I've got like 100 files, you can technically have the entire thing in one file, and then you can just email that to someone. Let me see if I can pull up an example. Let's see here. Desktop. No, it's under my GitHub. Did I make anything? I don't have anything on this computer except for some stuff I downloaded off of another. Well, that is an example. That's not a bad example. All right, I don't have any good examples nearby. Oh wait, here's one. This was, let's see. Here we go. So this doesn't actually like show a win condition or anything. It's kind of a variation on like the lights out puzzle. I programmed this up for a session of Dungeons and Dragons because I had a puzzle in mind, but it was going to be very time consuming to actually try and make it like to show like, okay, if you switch this lever, then these things turn on and off. And I was like, oh gosh, that's going to be a mess. So I programmed this up really quick. This is the entire code. It's just like that much. Let me zoom out a bit. That's it. 66 lines. It covers the web page. Technically, the background color, I guess, is in there, though I coded it instead of doing it in the style. But whatever, it works. But that's it. Like, it's just a little puzzle of, hey, can you get all the things to the same color? And it doesn't take a lot of code to do that. But the advantage there is that because it's all a single file, if I want to show that to somebody, I can throw one file on a USB drive, or if for whatever reason I can't do that, I can copy one file's worth of text into an email, or send it however, and there's no installation. Yeah, kind of like a Rubik's Cube, sort of. There's no installation or anything because JavaScript runs in a browser. If you have a web browser on a computer, you can run your program. You don't have to set up any extra software. That's why I really think JavaScript is a great learner language, is because it's super portable. It's not good for a lot of things, but I think for learning it's fun. It's got decent syntax, like the keywords and how you reference certain things. It's fairly standard stuff. One thing that people hate about JavaScript, and this is reasonable. I'm going to zoom in down here on my console here. People hate this about JavaScript, and with good reason. So, in most programming languages, you can have strings of text, like this. Have you heard of the app Learn to Code? I have not. You can have strings of text, like the word test, and you can have numbers, like 1, 12, 123, that sort of thing. And if I want to check to see if those things are equal, the answer is, of course not. They're false. Now, here's where things get interesting. The word 1, 2, like the word made up of the, let's say letters 1, 2, 3, is text. If I compare it against the number 1, 2, 3, in most languages, that says, no, they're not the same. You can't compare the characters, numeral 1, numeral 2, numeral 3, with the number 123. Those are not the same. Typically, what you'd have to do is say, okay, give me the string of that number. In JavaScript just tries to convert things to be the same type, and you can get into a lot of trouble with that. It makes sense if you learn a bit more about the history of JavaScript, but this is very annoying that JavaScript says these things are equal. There's an easy way around that, which is like a triple equals is like okay, it's equals, but no, seriously, it's really equals. And it's like, nope, it's not. It's not if you use the triple equals. It's goofy stuff, but every language has its share of quirks, and a lot of learning to program, like when you get kind of into the mid-level of learning the language, that's a lot of what you're doing, is kind of learning the weird quirks of the language. It can be correct until suddenly it starts comparing things in ways that you didn't want it to, and then it's bad. So that's why in my code a lot of times you'll see me using triple equals a lot instead of double equals, because it's like I always want to make sure no, these are really the same thing. Like, because sometimes it'll do some weird conversions. For instance, a blank string, like a word that has no letters or numbers in it, is technically equal to the number 0. It is also technically equal to false. It is also technically equal to an empty list of things, or a list containing an empty string. So there's a lot of really bad conversions it tries to do sometimes that make it very hard to debug. But the garbage teacher decided that was how the class was going to learn to code. I mean, I get it. A lot of times when you're teaching a large group, you just have to find something that's going to work. But it's really hard to learn in a big group like that. Learning on your own is really one of the best ways. And it can really come down to just like learning the very basics of, hey, make an HTML document that has a red background. That's it. If you can start there, from there you can build whatever you want. Like, if you start with just learning the very basics of HTML, app was laggy on the school hardware. Yeah, I bet there's a lot of extra stuff that, like with a coding app, a lot of extra stuff it has to do. There's a, let's see, is it Codecademy? Yeah, there's Codecademy.com, which is, I don't remember how good it is. I've used it before for some stuff. I remember they've got a lot of free courses available, which is, I think, fine for starting out. Right, we were kind of trying to figure out how we're going to make this bounce off the enemy. So what we want, yeah, it's a good place to start, I think. Let's just give him a little bit of red and him a little green because it's Christmas. All right, so bounce off. We want to bounce off the enemy. In what frame of reference? I think what we want to do. Okay, I think what we want to do. This is going to be weird to think about vectors and stuff. If the enemy is standing still, then I basically just want to ricochet off the enemy. If I get hurt. Maybe like at a set speed or something, but still. Oh, maybe that's what we do. If it's, we always go a set speed directly away from the enemy. So the way we calculate that is we draw a line from center point to center point. That's our vector right there. We want to push in that direction at some low speed. So if you come full on and then you get hurt, it's ow. You just kind of bounce away in that direction. If you come very slowly, then you get pushed away also in a similar, at the same speed. We'll try that for now. The trick is, what if the enemy is moving? Like, what if the enemy is currently moving, say down at an angle for some reason, at a speedy angle or otherwise. The enemy is currently moving along. Then I think what we need to do is add those vectors together to get the final speed. So we're going to try that. We're going to calculate the vector between the enemy and the player and add the enemy speed, and that's going to be the player's new speed. Yeah, that's Microsoft Paint right there. Yeah, it's nothing fancy, but it's good for mocking up little geometry puzzles like this, where I have to kind of play around with things. So that's what we're gonna try, and that's gonna create our new vector. That's gonna look like this. Our additive vectors. All right, so first we need to calculate the direction. Is there a way to download the app? Because it would be handy for your honors math class. The app Microsoft Paint? Are you using Windows? Because it should be pre-installed on every version of Windows. Just under the start menu, it's just Paint, I think is all they call it. Oh, it's a MacBook. I don't know what MacBook comes pre-installed with. I mean, I know that online there is a very good emulation of the XP version of Microsoft Paint. I don't remember the name of what they called the website, but it's a very true to form copy of the old XP version of Paint, which was a very good program for drawing, really. I mean, you can't do layers like in Photoshop or GIMP or anything, but you know, if you just want to draw some circles and lines, then perfect. So we're gonna bounce off the enemy by calculate difference vector player minus enemy. Then we're going to scale to set magnitude. That's the word. Then we're going to add enemy velocity. Oh, I think I kind of want to do this even if you're not injured. Like if you are touching an enemy regardless of... Yeah, I'm going to swap these real quick. I think. Yeah, let's move all of this code to right here. Add enemy velocity, and then we're actually going to do the bounce. So first, we need our difference vector. So let's see. We're going to call this our bounce X. Bounce DX? Yeah. So that's going to be the player's X minus the enemy... Oh, it's touching sprite. .x. Similar for Y. If we were using a real game engine, there would be built-in types to handle vectors like this, but instead we're just kind of doubling up the lines to do X and Y separately. All right, so there's our difference vector. DX and DY is just player minus enemy. The Wii U port to Switch. Yeah, it does, doesn't it? Funny how that works out. All right, so now we need to scale it to set the magnitude. So what am I talking about there? Let's scroll down a bit. Have another little area here to work on. All right, so I've got a vector. It's really hard. Used a bunch of new tech. Oh boy. New juggling tech, I bet. So I've got a vector that is made up of an X dimension and a Y dimension, like this. The sum of it is my total vector that I'm interested in. But all I really have is X and Y right now. So let's do Y. Yeah, that's beautiful Y right there, and X. And there's my vectors, the red one. Guilty. Called it. So what we want to do here now is I want to scale this down to a certain size vector. So for instance, let's say I want to scale it to a value of, I don't know, 5. Let's say this circle has a radius of 5 to indicate my my target here. So what I want to do then is shorten the vector to this point here. But keep in mind that I don't have the red vector itself. I'm not dealing with that. I'm dealing with the X and the Y, the blue line and the green line. So how do I cut those down by the right amount to get this new vector? Because I'm going to wind up with an X and Y like right here, which is a little bit rougher to calculate. What I'm going to do is I'm going to calculate how much smaller the small red is than the big red. Let's say that's like 35%. Then all I have to do is scale X and Y by 35%. And boom, I'm done. So I just calculate the size of the big arrow and divide it by, and there's going to be a division with the small arrow size. And that should be all we need. So let's see here. We need enemy velocity magnitude is going to be equal to math.square root of math.square root of bounce dx squared plus bounce dy squared. That's the old Pythagorean theorem for you right there. So that's our velocity magnitude, and then we want our target magnitude. This one's going to be kind of set in stone for now as 3 speed units, an ancient language. And so magnitude scale is, hey, what do we have to divide by to get down to 3 from this? Which is to say, this divided by, or let's say multiplied by this equals target magnitude. How do we get that? It's not divide by 3, it's, let's see, if that's 3 and this is 7, then the number I'm interested in is 3/7. So it's target magnitude divided by enemy velocity magnitude. All right, so that's what we need to scale by. So we're gonna scale down bounce dx by our scale here, and also bounce dy. Just scale them down to the correct amount, or up. Could be up. All right, but we got that. Now we add our enemy velocity to the mix. So bounce dx, add on to that our enemies dx. And same for y. And there we go. Now we can set, we're going to set our player speed equal to bounce dx. Not add it, we're just going to set it and see if that works out. All right, let's see what happens when we do this. All right, hang on. Gotta actually get up to an enemy here. Oh, bounce. Oh, I made a typo somewhere. Oh, there it is. Bouncy dy. Typical. Oh gosh, it's so hard to control. There I go. Whoa! Whoa! That's 3? That's speed of 3? Is that right? I'm flying away from this guy. I just instantly hit the... All right, hang on. Hang on. Tell me what that bounce DX is when I hit. How about that? We got a runner. Whoa, negative 1159. I might have made a mistake. I think a slight calculation error was made here. All right, what did I do wrong here? Was it my magnitude scale? What was my enemy velocity there? Oh, it's because I'm using... Okay, hang on. All right, that's part of it, I think. Yeah. I went from dealing with X to DX here at some point. Yeah, all right, hang on now. .05 to get that up to 3. All right, what I should probably be doing is right here. Show me the values of bounce DX, oops, and bounce DY. Let's do that. Okay, negative 883, negative 583. Okay, our problem is at that point in the code, these things are supposed to be scale. This ordered pair here should have a magnitude of 3, and it does not. So that's great. Okay, so we're doing this right. So this right here, I've calculated the difference X and Y between my player and the sprite. And then I've calculated, yeah, that's way too big a number. Okay. Square both of those, sum them, take the square root. And that should be the distance of my big red arrow right there. Which should be like, I don't know, 20 or 30. Something small. Oh, get back up there. Get back up there. Jetpack on up, young man. 60. Yeah, that sounds about right. That sounds about right. Yeah, that sounds perfect. So our velocity magnitude here is correct. We're getting about 60. Target magnitude divided by enemy magnitude. So we're looking for about 0.05. We're looking for a magnitude change of about 0.05, which is what we're actually getting. We are getting that. Okay. So I've found that, hey, this distance is about 20 times my target of 3. So magnitude scale is about 1/20th. Perfect. And then I need to multiply by my scale. Whoops. So basically we were off by about a factor of 400 as a result of that. So that's a fun bug. Always gotta think both ways about that. All right, so what happens here? Boop, boop, perfect. Look at that. Look at that booping. Look at that grade A booping. We are getting booped. Oh, look at that. That is perfect boopage. Oh yes. Boop me again. Oh, did you see that? Yes. S tier boop. Oh, it's beautiful. They should have sent a poet. So here's the advantage here. No matter how fast I'm going, like if I build up a ton of speed, I still boop off at a steady, flat velocity. I don't ricochet back at the same speed I was going, because that would just create some crazy wacky problems when I get sandwiched between things. I go down to a very normal speed. The goal, the reasoning, the goal there is that hitting an enemy is bad. So I don't want it to be like you hit an enemy and then boom, you bounce away from danger. I want it to be like you hit an enemy, boom, you lose your momentum. Now you have to face the consequences and deal with it. Oh, that's perfect. That is exactly what I wanted. Oh, that's good. That is really good. I like that. I like it so much. I kind of want to have an item at some point. I don't know exactly what it would be, but some kind of weapon or something that instead of firing something, you basically fire yourself at an enemy. Like, you lose control of your player for a bit, but you become a cannonball of sorts. Like, you become a damaging projectile. And then you can kind of bounce around off of things. Hilarity ensues. Oh, that's perfect. That feels so much better, honestly, than what... Like, that small change is so much better than just phasing through enemies. I like that a lot. Oh, they just kind of scoot you around. Oh, that's good. That is really good. Whoa. Yeah, I love it. Okay. Next up. Because I think right there, we're pretty good on what I was wanting to get accomplished for that one. I should bump the player health up while we're just kind of playing around. Because I'm gonna granted, I'm probably gonna forget, but let's do that. Bonk. Oh, should we work on some UI improvements maybe tonight as well? If I get fired from a job, I say call me again because I just got fired. Perfect. All right. Yeah, I think that's what we're gonna try. Is I do kind of want to do a little bit of UI. Basically, just a little bit of prettier, like, indicators up here. I want a health bar. That's what I'm getting at. I really want a health bar. Now, here's the question. I'm putting off the boss stuff because I know the boss thing is going to be a huge feature to tackle. All right, so let's find another square on this MS Paint document here. All right, so health bars. We got some options. That's the word I was very slowly trying to stutter out. I swear, I don't really have much of a stutter in the real world. It's only when I am streaming that suddenly I lose all ability to speak clearly for any length of time while I'm excited. There we go. So I moved for Twitch chatting as my dad's work laptop, and because he got a new job, I have to give it back to his... Aww. What are you gonna do? Got any other devices that work for that? Okay, something like... Alright, so HP should be integer values, discrete integer values. Like, you never have 3.5 health. You always have 3 or 4. Or at least maybe we just think about it that way. So based on that, I want to indicate that with our health meter here. I want to do the same. Oh, good. Nice. Oh yeah, that's gonna happen one of these days. I want to do something like this for health. Like little slightly outlined boxes. I think that's a good looking style of health. So it's like, boom, there's 10 health right there. If I had no computer, I would have to keep using your Fire Stick. Oh gosh. Yeah, that's no fun. All right, so now we got to make some decisions here. Health. When you assume at some point in the game you can upgrade health. All right, let's say you start with like 5 health, but you can work it up to like 10 or so. I don't know. So if I start at 5 health and then I can get to 10, I have to decide, when I get more health, does the health meter take up the same amount of space as it does at the start of the game? Like, I don't know if this makes any sense, but like do I grow from 5 bars to 10 like this, where like it basically each bar gets smaller, but you can see like, oh, I've got more bars of health, or do the bars keep growing outward? Hey, Slushy. How's it going tonight? Oh man, we got some new bounce physics. Now when you run into an enemy, you don't just phase through them and take damage. Now you get bonked away from them. They can sort of scoot you away, and it's really satisfying to just get bopped around like that. Hey, tank. Where your ball changes color based on the health. So the ball is temporary. Eventually we will probably have like actual hand-drawn art stuff, maybe, or some kind of procedurally generated block things. Hey, Shiner. Man, everybody. Muted? Surely not. No, I'm not muted. That's you. Man, now everybody's here suddenly. All right, well, everybody has to see what we got going on here. We got booping. Booping has been added to the game. Actually, I gotta reload so I can have my upgraded health here. So now, previously, when you touched an enemy, you would take damage and phase through them. But now, you actually get bonked around by them, and it's great. Oh, what happens if I get bumped against the wall? What's gonna happen? Hello? Guys? I don't know. Player.x is not a number. This makes sense, actually. I do believe that I divided by 0. Yeah. So if we come back to our chart right here, we've got the distance between the enemy and the player, represented by this red vector here. And we are trying to scale the vector down to a set amount to represent the boop vector. The boopage. The problem is that vector, we were perfectly overlapped with the enemy. Is the muting on the... The mic's not muted. Sorry. Yeah, the boopage vector. When the player and the enemy overlap completely, when there's a complete eclipse, the result is that this value is 0, and you'll notice a little problem when that value is 0 is that suddenly we are doing a divide by 0. So, what we have to do is basically just have a check in place to say, hey, don't do any of this booping unless that value is greater than 0. That was weird, Hudson. Very strange. Okay, now we're good. Now let's go get booped again. boop. It's just a very fun little bonk, bonk. So no matter how fast you're coming at the enemy, you always get bonked off at a constant velocity. Sight wasn't even muted? That is weird. And that is, I think that works to the design of the game. Because if you're just like speeding through the level, you know, you got all this momentum built up, you will be punished for hitting an enemy in that suddenly you are momentumless and stuck next to an enemy you have to fight. Versus if I reflected your momentum back and you just bounced off like a billiard ball, then you would bounce away to safety. We don't want that. We want you to have to face the consequences of your actions. Boop. And so you just immediately sort of get a very wimpy knockback. And I think that's perfect for what we're going for. Boop. Oh, I love it. I love this. Boop, boop. All right. So we got that working. Next up, we want to talk health bars. So this is a big subject, and granted, we're not locked into whatever we choose, but we are going to be looking at it for a long time after this. So let's say that when you start the game, you have 5 health, but that you can upgrade your health throughout the game to a total of who knows how much, maybe indefinitely. But let's say maybe you can upgrade it to 10. The question is, how do we represent the growth from 5 to 10? Do we just keep tacking new bars of the same size off to the side? Or does the health bar take up a set space and just the number of subdivisions increases? As a player, I lean towards this first option where we just tack new bars on the end, because that feels a lot more impactful. Like, oh, look at how big the health bar is now. But that creates a problem in the UI of, now I don't know how big my health bar is going to be. So I have to sort of, I don't know, I have to be ready for the health bar to potentially be a lot bigger than it is at the start. And if I allow the health to grow indefinitely, then I run into some big issues. Although, it could be possible to pull one of these guys right here.
Funny thing and a 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 funny thing.
It is a funny thing.
And a funny thing 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 and a funny thing. Dobbs, W love Dobbs. There are no 2 Dobbs.
Thank you for the funny things. So like I could do overlaying once I get past a certain value with a new color. That kind of pushes the problem down the road a bit. See, like that could be 16 health over 10 or something. Metroid does something like that. Like, I'm trying to think back to the old Metroids. Like, how did that work? It was like a number of extra tanks was off to the side. Like, after you peaked out at your 100 health, and you reached 200 health, it would just have an X2 off to the side or something to indicate that you've got an extra health bar. Yeah, I don't play enough Terraria to know. Actually, I really like the effect of a different color health on top of something, so I might actually want to save that. Part of it is I just don't know, like, how much health is going to be in the game. Like, I'd like to assume that every hit is 1 health bubble, because that's a lot easier to think about. I mean, maybe for now we just do. Maybe for now we just do a static size of the health bar, and we just increase subdivisions as max HP goes up. And then when you take damage, we do the Oops, not that one. Like this thing right here to indicate damage being taken. That works well. I think that's fine. So let's add an HP bar. So that's going to be in our main code, in our main draw function. We need some kind of helper for that. So let's add a UI. Overlay. Make sure to add it to our code here. It's not a map, it's overlay, JS. And we're just gonna have a overlay, let's call it overlay handler to match the other functions we've got, the other classes we've got for this kind of stuff. Like we've got a keyboard handler, mouse handler. Actually, it's just mouse right now. We should change that. Right now it's not a handler class. It's basically just a bunch of functions. All right. So in our main function, we want to make sure that we have an overlay handler, which is a new overlay handler object. And it's going to have a function that is, I don't know, draw. We're just going to do draw again. Okay. And you know what? Let's move all this stuff into the overlay handler. There we go. Just clean up our main function a little bit. It'll draw that last. So let's have our health bar. Let's set that in the lower left for now, I think. Sure, lower left. We need our boundaries. Left bound is going to be, let's say, 10 pixels off that. Lower bound is going to be canvas.height minus 10. Upper bound. How big is this going to be? Let's start with 40 pixels. Sure. And 40 pixels tall and 100 pixels wide. Sure. Spacing between bars. Ugh. Actually, let's drop this. Let's just have a left canvas height minus, let's say 50 for the upper bound. And then we're just gonna have we'll handle things like height and margin, that kind of thing. So let's see here. We want to have bar height. We settled on 40 earlier. And let's call it block height and block width, because that's for a single block. Is that how we want to do this? That's probably how we want to do this. They're going to be a little bit thinner. What did our mock-up look like? About 2 to 1. So let's call the width 20. Block padding between each. Just 2 pixels. Dang it. I'm trying to think of things like size of... I don't know, it's fine. Player dot HP, is that what Player's got HP. Oh, player does not have max HP. Interesting. Do sprites have HP? Sprites do not have HP. Do sprites need HP? Alright, let's say... Alright. Currently, every sprite has an HP value, or every enemy and player has an HP value, but we don't store a maximum HP. It's weird that you have 2 followers on Twitch even though I've not uploaded anything. Probably not. Let's see here. Is it useful for enemies to have a max HP? Do we care about what HP an enemy started with? Probably, because what if we want to add, like, I don't know, something that lets you see an enemy's health bar, or maybe enemies get the ability to heal at some point, like there's some enemy that can heal nearby enemies. In that case, we would want that. And so that means that HP needs to be a property of sprite class. And also, do we not have an initialize? I guess not for sprites. We got a constructor. Does this work? If I take this out, let's find out. Seems to work. Yeah, okay, he's still got 3 HP. Okay. Is there anywhere else where I say HP equals? Yeah, this guy, I say... So let's change that to max HP is 50. And enemy, we're going to leave it as the default 3. Okay, so now max HP is a thing. Officially. All right. So now we can iterate over the player's individual HP blocks and draw them each. And that's going to be pretty easy. We're going to do ctx.fill style. We want a nice deep red color. I don't know if dark red is going to work. What is this color that we used? This looks pretty good. Edit colors. What is this one? 12800. Perfect. So that's going to be a nice 800. All right, and so we're going to then draw a rectangle for each of these. ctx.fill rect. Is that it? Wait, is it not fill rect? I feel like that's right. Yeah, it is. We're going to start at the left bound plus add our interval times our block width plus our block padding. That's quite an X value right there, but that is what we need. That's our X. Our Y starting value is just going to be upper bound. Width is block width. That one's easy. And height is block height. Simple as that. Okay, so that should just make a bunch of dark red rectangles. Like a lot, because we got 50 health. We went a little bit overboard. Sounds good, Hudson. Yeah, you gotta make sure you're doing that homework. I don't feel like that's dark enough for the outline. Kind of want to go a little bit darker than that if we can. Let's go 5. All right, and then we're going to iterate over regular HP. We're going to do the same thing, except we're going to add 2 to our X, and we're going to subtract 4 from the width and height. So if I'm doing this right, what this should basically do is do outlines. Let's do a 100. Hey, look at that. Look at that good-looking health bar. Block padding is a little bit too big. I want less space between these blocks. All right, that's a little better. Yeah, that should be fine. Okay, player, max HP, 50. Constructor did not do the thing I wanted it to do, which is I wanted it. I put it in Sprite.js. Yeah, I wanted to set max HP equal to this.hp. I must have done something here, right? Like player HP is definitely 3 right here. Yeah, it is. But max HP is 50. That's correct. I bet maybe. Well, now I'm not sure. Interesting. Player does extend sprite, but does it not call the constructor? It must. It must, because I'm giving it a position. Oh, I wonder if this gets called after the constructor. Who's the best player at Super Mario Maker 2 off the top of my head? Best at what? Because I'm thinking like, I know there's some players that are particularly good at precision levels versus shell jump levels versus, I don't know, general Kaizo versus mode. I know there's a lot of great players out there, but I wouldn't want to try and say who's the best overall, like overall in tech and shell stuff. Shell stuff. Probably someone I've never heard of, honestly. If I had to guess. Probably someone that doesn't even stream. Oh yeah, Leech is really good at tech. So this doesn't work. So that means what I need to do I guess I need to have an initialize function for these. That's weird. So when I'm... Oh wait, no. Sprite initialize. There is an initialize function. Where is it? Oh, it can be individually defined by the class. Oh. Okay, that's fair. SpacePic's really good at shell stuff. Yeah. I don't think I've ever seen does SpacePig actually like put out any videos or anything, or is it just the levels that they create? Because I don't know if I don't know. Oh, he's a late streamer. Gotcha. I would hate to have to define this every time. Hey, Gamer Games. How you doing? So I think what's happening So these properties are getting set after the constructor is getting called, which is very strange. I wouldn't expect that. So I'd like a cleaner way to set the HP equal to the max HP when we initialize. Oh, I know a way we can do that. What we can do... Well, this is a way. It's not a great way. But it will work. Wait, maybe it won't. Cool. Ooh, I see. All right, hang on. We got this. Don't worry, everybody. Hold tight. All right, that should do it. Okay, now we've got 50 health. Never seen Failstream. I think I remember seeing something about a hard cape level a while back. All right, now let's set our max HP of our player down to something a little bit more reasonable, like 10. Okay, now I got a reasonable amount of health that we can view. And now what we're gonna do is take some damage. Hey, and look at that. It decreases correctly. So now we have a good little UI for HP. Make sure that that's gonna actually make sure the player is actually going to get deleted at 0. Perfect. And then it goes back to 10. Yeah. That is pretty crazy. All right, do I like how this looks? It's a little bit of a sharp red, but maybe that's all right. We could do a more transparent color, I think, with something like this. Ooh, look at that. That's actually pretty nice, because now you can actually see behind it quite a bit better. Yeah, I like that. I like that fine. Maybe as a result, we want to take kind of a... We want to get a little bit of a more... slightly more opaque color for has health. There we go. And then it kind of grays out a bit. That looks alright, I think. Do we still want the space between them, though? Oh, thank you all. Let's see what happens if we take the block padding away. And we just get this one constant. It's this one big connected bar. Yeah, that's alright. Let's see. Block border is this 2 I've got here, 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 and here. So if we take that down to 1, yeah, we get a little bit crisper. And then we can have bar border equals 3. And that's going to be behind the whole thing, I guess? Or should I do a line around it, maybe? Maybe a line around for that part. So we'll do like a stroke style. Let's just say black, low opacity. Line
Actually,
width.
I think Hudson is the best player at every level in Mario Maker 2. He told me to say this to build up his ego.
Love it. And there. All right, perfect. What's going on, Abel the Above? We're doing just some casual little for funsies game development. Working on a little bit of UI tweaks before starting to take a bigger bite out of some difficult stuff I've been putting off for a while now. Let's see here. We're gonna do a, oh gosh, what is it? What? Line 2. Is it line 2? No, move 2? Move 2 is the first one. Weirdest syntax. I've never really understood it. So we do left bound. And we're gonna go a little bit further out. And then our upper bound bar border. I should just do a stroke rect. That's much easier. I think that's the command for that. X, Y, yeah, and then width and height. Yeah, raw vanilla JavaScript. TTS makes you blush every time. That's good. I'm a fan of vanilla JS. I like TypeScript, but we're just kind of playing it a little bit loose and casual with this, so I'm not too worried about the inevitable problems that will happen if this project gets big. But it is. I was telling Hudson towards the start of the stream about all the fun things that make people like really hate working with JavaScript. Which, I mean, granted, given JavaScript's history, it makes sense that it does a lot of like weird loose comparisons. But in a modern environment, basically, if you are ever using double equals instead of triple equals, you are doing JavaScript wrong, and you're gonna have a bad time. Block width. Oh no! Now I need the whole thing. Oh, Rust fan. Nice. I still haven't actually played with Rust at all. At my job, I do a lot of, well, I actually do some JavaScript at work, but also C#, Java, and good old VB.NET. We want to have, okay, this one's going to be an ugly one for this width here. I probably should try it out at some point. Honestly, I've been kind of out of the loop on a lot of new stuff. Like I totally missed the boat on Go. I haven't touched anything new in so long because my company is kind of a little bit backwards at times. Hey, thanks for the follow, by the way. Never heard of Rust. Yeah, I had a friend who was really pushing. It was one of the functional languages that was kind of really popular about like 5 or 6 years ago. They were a bit of a zealot for that. All right, let's see here. Full, or let's say total block width. So a single block is our block width plus the padding on either side plus the border on either side. No, the padding on either side. Yeah, border on either side. So that's a full block, and then multiply that by the total number of blocks, which is our max HP. She was switching my Twitch name color. Oh yeah, I did notice that it changed, didn't it? From like it was red a little bit ago. No, it was green. Now it's blue. Yeah. I have trouble keeping up when that happens. I'm like, wait, who are you? Oh, I was just talking with you. Never mind, we're good. So we'll do with the total block width. Then we're gonna do this bar border. And then we're gonna do our block height plus bar border times 2. Let's get some actual spacing in here so I can read this. My goodness. All right. let's see how that works. Oh, wait, how did we wind up with 1 extra? Wait, what? That's fun. Went from red last week, green this week. You're just kind of changing for the seasons. You're getting red and green. And now, you know, a nice Christmas blue. Yeah, Hudson still doesn't really have much experience. Like, he has not started to learn programming just yet. I've been giving him a few places to kind of at least get his feet wet. Yeah, let's go with that. But really, how did that happen? Player max HP is 10. 4, 5, 6, 7, 8, 9, 10. And yet, we have space here for 11. All right, so let's say max HP is 1. Then what does this look like? Block width, 20. Block padding, times 2. That's 0. Block border, okay. Total block width. Huh. Well, that would be weird, wouldn't it? All right, player. What happens if you have an HP of 1? Oh, it's just coincidental that it looks like it's just enough space for 1 extra. But actually, it is right here. Block border times 2. Tips have been helping. Good. I hope you do kind of try out some coding stuff. It's a lot of fun. It really is. What's our block border coming from here? Do we really need 2? How have we been doing that? I don't think we do. Let's take this out. Kind of just trying to cobble something together here. Yeah, 220. Oh, block padding is the no? What is block border then? Yeah, block padding is the space between. Actually, let's leave some comments here. Splice. Oh my gosh. So this is VS Code. It's a lot more lightweight than Visual Studio. It's free. It's got a lot of useful features to it. I like it. It's heavier than Notepad++, I'll say that for sure, but my computer doesn't seem to mind. Block border. Dark red border around individual blocks. Oh, okay. Block width, block padding. Ah, not times 2. And also block border. Whoops, does that needs to be in here, doesn't it? That's probably why I'm having issues. Well, never mind. Alright, screw it. Get rid of block border. What does that do? Yeah, I don't want the full... I don't want that. Jetpack activate. Yeah, see, that's a continuous line. I do want the block border at least a little bit. But really, it does need to be on... Yeah, I think this does need to be here. There we go. That's getting there. That's getting there. Let's increase the size of some of these items here just to make sure we can see. Yeah. So the problem there is it's the this one's not centered properly. So does that do it? There we go. That's more like it. Just realized you can get Smart Notebook on MacBook because there is no Microsoft Paint. Yeah, the Paint is handy, but honestly, piece of scratch paper is just as good for that kind of stuff. All right. Last little bit is I noticed that the margins don't add up on the right because we're adding them one more time. So we need to subtract one final block border, I think. Is that right? Yeah, there we go. That's nice and centered. All right, so now let's drop the padding to 0, drop the border to 1. And also, what else? Wait. What if this? What does that look like? Okay, yeah, we don't want that. Why do I still have space between these then? I think I tried to make this too configurable, honestly. Too much space. Ha! Alright, let's just drop this entirely. I was trying to get too fancy. I'm just really trying to put off the boss stuff. Alright, we have HP. We have the HP stuff that I wanted to get done. We're gonna at least try and get our feet wet with this boss system. Okay. So let's scroll ever downward to another blank spot. Boss fight. So, here's what I'm thinking. A boss is made up of a lot of subcomponents, a lot of individual sprites, not one big sprite. And they each have different things they do. So far the ideas I've got is that you've got your, whoops, let's get that back to white. You've got these controller pieces. And what they're gonna do is basically, they're here to manage other pieces. Maybe there will only be one or something, but this is kind of like the parent element that handles the position of everything else. All right, so these are like the glue that holds a boss together. It's the joint that keeps everything in place. They are going to have other pieces in orbit around them. All right, maybe that actually serves as the core, like the boss's main health as well. Maybe it can pull double duty there, but very important piece there. Because it's going to contain a list of other parts, and it's going to provide those other parts with a target location, which typically will be in the form of like slowly rotating around the boss or something like that. But it's going to manage the position of all these other elements and tell them, hey, you need to be moving in this direction now, because I myself am moving to the right. Therefore, you want to move here, and then the other pieces will slowly line up correctly. And then we're going to have weapon pieces, various types of weapon pieces that will be similar to regular enemies, except they are being kept in a certain orbit or position by this core. So these things could be doing anything from just shooting small projectiles to shooting... I don't know, some kind of like homing missile thing, whatever else. All right. Then you'll have a few other utility pieces. We'll have like a shield core. I haven't exactly decided how these will work precisely, but I'm thinking that they will center a shield around themselves, which, you know, what good is it to block yourself? The thing is, they're basically going to be body blocking other things. And since there's going to be a lot of these elements rotating around, it will be able to form a sort of paneled shield as it moves around. And I'm thinking maybe like the shield like loses power and has to like recharge every once in a while so that you can actually deal damage to these shield pieces, chip away at them, so that you can shoot through the gaps, that kind of thing. But they'll basically kind of create this little bubble that will delete all player projectiles so that the player can't do anything about it. Not sure if there's going to be anything else. I mean, that covers the main pieces. It's basically like the core, the offense, and then some kind of utility stuff like shields, maybe some other things. I could have some pieces representing other representing stats of things. For instance, maybe there's some large pieces that represent the thing's engines, and the more of those you take out, the slower the whole conglomeration moves. Or maybe like the slower the rotation of the elements goes, the more engines you can take out. So maybe we'll have some engine pieces in there that they themselves do not do anything. They are basically just a placeholder of, hey, if you do this, if you knock this thing out, then that's going to make your life easier. So maybe we'll have some of those floating around. So let's see, we got, you know what? There is a text tool in here. So we got engine, we got shield, we got weapons, and we've got the core. Trying to think if there's anything else that makes sense. All right, take care, Hudson. Do good on your homework tonight. All right, what else could we have? And I'm thinking that different bosses will have different sets of these things. And here's a big fun thing. I think that a core in its orbit could have another core, which in turn has its own little subset of things. And you could have basically look, you know, like not every boss is going to look like a big circle of parts spinning around. Since you could have cores that have cores, you can have these really cool, like, nested orbits that do all these sort of wacky things. Especially if you set up the tree structure correctly, you could have it that like the main piece, the main core doesn't even have any rotation going on with it. Like its pieces are set in stone, but then you've got basically like these what could look like giant arms made up of smaller pieces that, you know, are covered in missile-bearing weaponry. So, got to come up with something like that. Something to handle that sort of thing. So maybe the engine handles the movement of the core, but maybe the rotation is something separate. Piloting, if we want to think FTL. And who doesn't want to think FTL, honestly? Yeah, so let's say that there's a piloting system that controls the course that things travel or something. But yeah, we'll get these sort of orbiting pieces flowing around. So I've got this base class for boss part. And so this is going to get real ugly real fast. This is kind of why I've been putting this part off. Is because I know that this is going to be a pain to deal with. I got to think about this. All right. Eventually we'll want to have these all in their own little separate pieces, but I think the main code will be handled by the core. That will be the only... Will that be the only enemy? Maybe. If an object exists in the list of level enemies, then its update functionality is called. I think what I want to do is have the core manage the updates of all of its children. That will, I want to say that'll reduce some issues related to like order of operations. Like the core should move first, and then these other pieces. I don't want to get into a place where like, oh well, we kind of scrambled some things around and. Well, that does create one problem. Draw functionality is also tied to the list of enemies, in which case we gotta load it all up. What's our drawing functionality look like for sprites? Main sprite draw is pretty simple. Draw a circle. Yeah. Main code for drawing that is basically just... Yeah, for each sprite in our list of sprites, call sprite.draw. Very straightforward. Can't make it much simpler than that. So yeah, I guess I do want to have... Yeah, I don't want to override the update. Yeah, we'll let all these things be added to the list of enemies. But I need to make sure... Oh, actually, that's not too hard at all. The boss can have an initialization function. The core can have an initialization that sort of news up each object, and that way it can manage. It'll have a reference to each one. How am I gonna actually organize a boss? How configurable do I want these things to be? Like, what does that look like? Like, okay, I want to have a core that has, well, you know, my core is my object that has, oh yeah, it's got HP of X. It's got rotation speed of Y. It's got actual movement track of these bosses. That's going to be an interesting one. Basically, it can just like oscillate on a sine wave or something simple, or maybe just do a patrol on a certain timer, bounce back left and right for a while. And then its children are an engine. Well, that's going to be a list, so it's going to be an engine object. You know what I mean. It'll be an engine and a shield that has these properties, and another shield, and a weapon of missile type, and a weapon of laser type, And the tricky thing is going to be when we want to do another core. Then it's going to be like, okay, one of the children is a core. That is going to be tricky. So basically when we new up... Ugh, when we are defining a boss fight like this, it's all going to be one object, but it's going to be so much configuration to set it up. Ugh. But, I mean, probably worth it. What controls... Okay, distance from the core. That probably needs to be controlled by something as well. I want to say children should be able to override both the rotation speed... Is rotation always going to be just a linear sort of thing? Just constant speed around a core? Or should that be more configurable and allow for a little bit more interest? Oh boy, there's so much cool stuff that could be done with this. And I'm in that scary spot where I feel like if I the choices that I make now are going to drastically change what I will feel is possible later. We just gotta kind of do it, don't we? All right. We're gonna have a boss core enemy. Alright, yeah, that's fine. Let's just do it. Okay, just gotta set the max HP, set a color. And then an update function. That's pretty much the main piece I need here. Children. That's gonna be the weird one. I mean, we can hard code for now, but I think at some point there's gonna be a very interesting constructor here or something. Or maybe I override the boss core class with a few subclasses to deal with different types of bosses. I don't know. Ideally, I'd like for them to be able to be like randomly generated so that I just don't have to deal with it. Yeah, it's fine. We're gonna have plating as a type here. And it's basically just there to soak up damage, and that's it. And it'll just be a dark red of some kind. Let's brighten up this red a little bit. Very low HP, it's just there to provide kind of a little bit of shielding. In fact, its update function is do nothing, I think. Right? What's the Goomba do? Apply gravity. Okay, we do need to update our position based on our velocity. That's it, though. right. Does this work? Yeah, I didn't think so. Wait, at line 11? Oh, no. Boss one. Oh, whoops. Oops. Alright, level handler. Oh, that's from the... oh, I'm getting booped into a wall. Let's see if it works. Okay, I didn't get slammed into the next parallel dimension this time, so that's progress. Room generator. What makes a player? New player. That is in our level handler. When we load a zone. So if I just do new boss core at 700, 300. Hey, there he is. Perfect. And he doesn't move. Just as intended. All right. Initialize. When we are initializing it, then each children just gets pushed onto the map, right? Yeah, that does work. Okay, cool. I can just 0-0 this for now. So let's see. We're gonna say rad per child is math.pi times 2 divided by number of children. So let's see what happens if we basically just have 4 children to start with. Distance. Let radius. Orbit radius. Oh, actually, that needs to be a property of the boss core itself. Let's say 100, I guess? Sure. This dot x plus... Ooh, wait. Let's iterate over the numbers here. Children sub I. All right, so we're gonna push the child's x to core x plus math.cosine of radians per child times I, all times orbit radius. Similar for y. Swap out the y, swap out the cosine for a sine. What does that look like? Nope, child is not defined. Ah, yes, that makes sense. Hey, look at that. Plating. And each of these should have 2 health? Infinite health? Okay. Sprites. Give me sprite number 33. Plating. Dot X 700. Dot Y 200. Okay, give me sprite 31. 700. 400. Perfect. That's the one. HP is negative 23. Well, that's cool. So why is it not dead? What? Huh. Okay, hang on. Player bullet. Damage it. Touching sprite.hp. Alright, so where's our code to delete the sprite? Enemy JS, shared enemy update. So that's not getting called for this? Well, I've got the kill for it. No, I didn't. The kill is for another one. Oh, wait a second. Yeah, it's dead, but I didn't get a kill for it, so this is not happening. Where's our shared enemy update coming in? Oh, ooh, I have to do that manually on each one? Is that true? That seems wrong. I wish there was a better way to do that. There is. Ha! I know of a better way to do that. When I'm doing my updates, if sprite instance of enemy, then sprite dot shared enemy update. Boom, that should be all I need on that. I think. Let's see. Ah, I got bonked. I mean, it's perfect. There we go. Nice. Oh, that's satisfying. Loot needs to disappear after a while, also, now that I think about it. Boop. Good. We have a boss. It's a pretty ugly one. Doesn't really do much yet, but it will. In fact, should we up the... Should orbit radius change over time, maybe? I don't know. We'll see. All right. We're going to update my position, but then all of our children are going to get new positions. Let's see. I'm going to have some kind of timer element here. Just to keep track of how long this boss has been active. Let's see here. Yeah, this is just going to forcibly set it to a certain location. I guess that's fine. Let rad offset equals let's just say timer divided by 100. Let's see if that works. No, because timer is not defined. This dot timer is, though. Hey, we have a slowly rotating thing. All right, nice. Oh, and because the number of children does not actually change, this still rotates. Perfect. Okay, now what happens if one of my oh no, that's gonna be recursive forever. Yep, call stack size exceeded. Okay, yeah, that's fair. That's fair. Yeah, because it in turn will also have yeah. And it'll just go on forever. Anybody who's got it? There it is. Okay, so it's just super is the call. It's got to be the first one. All right, so my plan is to have a boss core that does not have children, I guess. Somehow. No, I can't do that easily. Let's just, all right, let's just do this the really quick and dirty way, just as a test. Boss core 2 has an orbit radius of 50 and does not have a, there we go. Boss core 2. Oh, look at this monstrosity. Oh, but it still rotates. Oh, it looks like it's rotating around at that same thing. Oh, because the rotation. So rotate speed has to be a thing. Well, that'd be easy enough to do something like this. Ooh, now that's pretty neat looking. Oh, yeah. All right, all right. I'm digging this. I am digging this. Let's do this. Oh, look at this boss monster now. Oh, yes. Oh, that feels very good to just, like, chip through. It's going to be a nightmare once there's, like... once it's just covered in missiles firing at me. But for now, that's actually pretty cool. That boss cores can themselves have boss cores. All right, let's drop that and let's just do this. Let's just make it out of smaller boss cores. Oh. All right, spin that faster. Spin that faster. Whoa! Oh, that's nice. I kind of want it to spin in the opposite direction, I think. Do I? Maybe? Let's see what happens. Ooh, actually, yeah, that does look pretty cool. Very buzzsaw. Oh, this is good. Wait, but what if there was a Boss Core 3 class? Oh no. Oh no. What am I doing? Whoa! All right, hang on now. Let's slow that down a bit. Alright, now what happens if I get stuck in there? Let me in. Oh, that's nice. You know, actually this very rudimentary bouncing thing, surprisingly effective. Oh, that's good. And somewhere in there is the main central core. That's cool. I gotta zoom in a little bit more. Let me in there. Huh. Oh, that's nice. I do like this. Oh, man. Oh, it's really hard to... Oh, wow. If you just focus on one of them, there's some serious spirographing going on here. Oh, this is pretty cool. So basically from this, I can make... Like right now I'm just copy pasting the entire core code, but if I move those out into some nice helper functions, it will be very easy to make reusable core chunks. Like these little individual spinny buzzsaws that there's 8 of right now. Like I can turn that into a very reusable component. And basically it could become like, alright, this boss is going to have spinny buzzsaw death fist and crown of missiles and other thing, and you just like basically pull out of a hat like what kind of weird parts this boss has, and it can all be based on the same reusable set of functions. Oh, this is good. This will be very interesting once I get a little bit more progress on it. But this is a great launching point for some really fun stuff, I think. So the plan is, let's add our to-do notes right here at the top. Let's do these guys here. All right. We're gonna have. I'm gonna jot down the different types of engines, different types of parts. Core manages location of child elements. Plating. This one's new. Let's capitalize. Let's go all caps here. No effect. Just a damage sponge. Engine. Presence. Well, when destroyed, lowers orbital speed for parent core. That'll be really cool, because like if you take out some engines, then like suddenly this like perfectly geometric order like will suddenly break down into this like chaos, which is exactly what you'd expect. Shield periodically blocks damage to something. To self and sibling part. Let's say. I don't know. I'm on the fence about that one. Exactly what it's going to do, I'm not sure, but somehow it's going to prevent damage on a timer. Yeah. Piloting? Does that make any sense to have? Motion of the of a core. Like orbital right now is managed by maybe this one's a bad idea. Let's drop this one for now. But I feel like the whole piece could move around. Because otherwise, you're going to have this weird situation where, like, the boss is always a stationary thing. Maybe that's good? Move entire boss around? Maybe? Weapons. We want, seeking missiles, bullets, flamethrowers, maybe? I don't know. At that point, we're getting into some crazy amounts of sprites floating around. Because the flamethrowers, if I remembered how I was going to do that, it's going to be similar to the jetpack of sort of a low... It'll be a low damage projectile, but a lot of them. So, yeah. We'll... Lasers. All sorts of things. We'll throw out a bunch of attacks that can be done. Right now, no enemies attack, so good to have something at least. Anything else? Engine, shield, core, weapons, maybe piloting. Still want to think of some other possible core pieces, because this could make for some very interesting gameplay if you can pick out and identify, oh, I need to knock out that piece specifically. If I can take that one out, then that's going to make it a lot easier to continue doling out some damage on this thing. So that's the idea there, is that these bosses will look complex, but they'll follow very straightforward rules. And if you can recognize, okay, this boss is really heavy in shields, then maybe you need to take out something like that. Power? A power core? Maybe? Like, all the elements on a core can't function without power, and if you can target the power core, then, like, intermittently some of the things just don't work. Like, let's throw that out for brainstorming. For all parts to function, destroy to interrupt that ring. So if a core's children, if one of the things on the child is a power unit, and you take that out, then intermittently that will cause something to fail, like the weapon won't fire, the shield won't engage, the engine won't be providing power, or something like that. Something like that. I don't know. That could be all right. Anything else? I want to put the player inside of this mess. Oh, he just kind of got spit out. Oh, he's in there. He's in there. Okay, that works. Yeah, the system, like, it deals some damage, but the system doesn't glitch out and throw him into a parallel universe. I think that's good. All right, I changed my mind about the overlay color suddenly. I want green. At least that's an easy swap. Oh, that's too green. That's too green. Oh, tone it down. Tone it down. Bring it down to an A. That's all right. Nice. Very bouncy. I like it. It works, like, it's such a... The deflection thing is like a really simple thing that I'm really surprised on how reasonable it looks. Like, the physics are hardly worthy of being called physics, but they just kind of, they do what they need to do. All right. Closing down Notepad here. I think this is gonna work. Like, going into this, I was a little bit worried on what I was exactly gonna do with this boss stuff, but this actually, I'm getting some ideas that could work out pretty well. All right, I'll publish this out at the usual place, which I totally have the link handy all the time. There we go. I'm just gonna throw that in the chat for the VOD. It'll be published pretty soon. Moon Rover bosses. Yeah, so right now it's every level just spawns with a boss, and there's nothing you can do about it. But eventually we'll make those only happen in the boss room, with appropriate pomp and circumstance. Nice. Oh man, you can rack up a lot of treasure here. Just gonna sit here and fire away. Oh yeah, the cores have like 10 health. They take a lot longer to chip away at, huh? I haven't seen any of them die. I'm sure it's fine. Oh, there they go. Oh, look at this. When you take out a core, its child elements stop moving. Because the core is what handles the movement. That makes sense. Huh. I like it. I'm down with that. Alright. That's the end of this one. We'll be back Sunday for Mario Maker. That's fun. Alright. Night, guys.